is Francis Duah, and Andrew is one of my students. He's an undergraduate student doing engineering degree, but he's writing a thesis in mathematics, focusing on statistical methodology for evaluating mass education interventions. And so he's going to tell us a bit more about some of the mass interventions that we have at TMU and a methodology that we intend to use in evaluating one of those programs.
So as Professor Duah said, my name is Andrew. I study engineering and I'm currently doing my undergraduate degree. And this is some work on my undergraduate mathematics thesis regarding propensity score analysis, or PSA. So before we begin, I just wanted to give a brief overview of the topics I'll be talking about. So first, I'm going to be discussing what is ACES, which is a maths education intervention program at TMU. Propensity score analysis and how it is an alternative to randomized controlled trials, also known as RCTs. The insights from applications of PSA to simulated data, and then reflections of PSA methodology and its future applications. So just some background knowledge. Many first-year students often find it quite difficult from the transition from secondary to post-secondary mathematics. Overall, it's quite strenuous on first-year students, having to deal with an extra course load, and there are often some gaps between secondary mathematics and post-secondary mathematics, most namely the courses MHF4U and MCV4U, which is the equivalent of calculus and vectors and advanced functions, respectively. Overall, these gaps in knowledge for high school students present mathematical anxiety for a lot of first years, which lead to lower course marks and lower retention rates, and many students having a weak foundation in mathematics. So that would impact students all the way from their undergraduate to continuing studies or graduate degrees. Because of this, many universities throughout Ontario and I guess throughout Canada as well have certain intervention programs meant to help these students. They go by different names throughout Canada and I guess Ontario. However, they all have the same purpose, which is to help students do better in mathematics by intervening. We have one of such at TMU. It is known as ACES. Now, ACES has been running since 2016, so it's been close to a decade now that's in operation. ACES is a maths intervention program run by the Faculty of Engineering and Architectural Science in collaboration with the FYEO, which stands for the First Year Engineering Office. The main goal of ACES is to help students do better in maths and keep them in university. And although ACES is very good, with its main goal being improved grades and understanding in mathematics courses, we aren't quite sure how effective it really is. Is it really helping students? Is it really giving the output that we want? And because of that, I find it important that we evaluate these processes, that we evaluate how these intervention programs, how effective they actually are, if they're really working, and whether we should change things. Because if something doesn't work, it's a good idea to change something about it. And that brings us to how to evaluate mathematical intervention programs. The gold standard of most analyses for these type of programs is using RCT, or randomized controlled trials. Now, RCT is, although it is quite known and is very good, it does present some challenges, notably some ethical challenges in terms of evaluating these intervention programs. It's quite unethical to deny services that would prove beneficial to students. And additionally, there is self-selection bias, which is typically where students who feel like they would do better in mathematics generally would pick themselves to participate in these programs. So with this in mind, we can't accurately or in good conscience produce results on whether these programs are effective or not. And that's where I present propensity score analysis. So propensity score analysis, also known as PSA, is an already known and used statistical methodology within numerous other fields, such as medicine and finance. However, it's not quite known in the maths education field, which is what I want to talk about today. So going more in depth into what PSA is. So PSA is, well, a statistical methodology that basically takes the base characteristics of a variety of different individuals and gives them a propensity score. Now, that propensity score is used to match these individuals within a treatment group and a control group. These matched individuals will be used for the study, and the unmatched individuals will not. Now, looking at these matched individuals, we can confidently say, based off a number of covariates that you can assign, which are their baseline characteristics, such as socioeconomic status, domestic or international students, a variety of different factors that would impact how these students perform in their classes. And by having the same baseline characteristics, we can confidently say, okay, these students are practically the same or as close as we can get. Now let's see how they differ in terms of one goes to this program and the other one doesn't. Now through this, we can address the biases that are evident in RCT, and we can simulate real randomization without the worry of self-selection bias. Now, going more into the mathematics of propensity score analysis, propensity score analysis has a lot of mathematics behind it, but to really simplify it for the sake of time, it really comes down to this formula, or well, yes, this formula. So propensity score is it's defined as a conditional probability of receiving a treatment given by pre-treatment covariates. So one would see it is typically just the logarithm of the treated group over the untreated group, which is equal to the covariates that you would measure. So as I said before, socioeconomic status, international status, the amount of courses a student would take, multiplied by the coefficient of those covariates, how important they are to the student, how important they are to studies themselves. Now, these are some of the covariates that we gathered for the ACES program at TMU. As you can see, it covers a wide variety of categories such as demographics, a student's age, gender, ethnicity, behavioral factors, so their lab attendance, and academic variables such as living situation and their previous high school grade point average or grades. Now, how do we simulate the data? Simulating the data, typically, or at least in our study, we use R. So using R, we gathered all the covariates that were needed along with their associated data points. From there, we generated around the same amount of students that were typically accepted into TMU's engineering program, which is around 1,300. And from there, we assigned them their propensity scores, and then we matched them. From matching, we are able to assess the differences in how well they academically perform, whether they are in the treated group, which is students participating in the ACES program, or the control group, which are the students that are just not participating. Now, from this, we can generate two graphs, or well, a lot of graphs, but for the sake of time, we include two, which is first a jitter plot of the matched and unmatched students, showing the amount of students that were in the control group but are unmatched, then the control group and then matched, and additionally in the treated group and was matched and unmatched. Generally, in most studies for PSA that we looked at, for treated groups, there are typically none or no unmatched cases, typically because there is generally less treated individuals than control units. Additionally, we can get histograms of propensity scores to show the distribution in propensity scores for treated and non-treated groups before and after their matching, which helps in determining the differences later on. Now, after propensity score analysis, it's important to note that propensity score analysis, it's not the final step. You're marinating the chicken before you're cooking it. Yeah. You're just getting ready for the next step, which is applying t-test or ANOVA or various other regression analyses to really find whether it's actually applicable or not, whether PSA is picking up if ACES is, actually helping students. Now, there are some challenges with PSA. PSA is not perfect. Some of the challenges include you have to be quite proficient in R. R is a highly well, I wouldn't say highly, but it is a technical software that, if you're not familiar with, can be quite difficult to use propensity score analysis. Additionally, propensity score analysis typically needs, I would say, a medium around sample size. having a sample size that is too small would result in too few matches, which wouldn't really draw a very solid conclusion, whether if this program is helpful or not. And additionally, having a too large, sample size would mean that it would take a lot of computational strength. So you should have a pretty strong computer. Now, direction for future research. Our real direction is that although we did simulate data mimicking propensity score analysis and how it is applicable to ACEs, we want to collect real data. So in the future, we hope to approach ACEs and approach the Office of the Registrar at TMU and get real data on these students and find a definitive, answer on whether this program is actually helpful or not. But in general, we want to just make this more evident in the math education community that PSA is a viable option other than RCTs. And what we hope to deliver in this is a better alternative. Additionally, there are some other exciting things for PSA in the future, such as integrating machine learning into it and finding the optimal covariates that we could use in our studies. And then, I guess I'm gonna go back. And then, addressing some of its limitations. So although PSA has limitations, hopefully sometime in the future, we'll be able to address these limitations, such as small sample size and get more solid conclusions. Now, these are some of the references that were used during the study and during this presentation. A lot of them were PSA studies themselves from other fields of study, such as medicine. We referenced the medicine one a lot, and finance, and a lot of other fields. Thank you for listening. I hope this educated you about PSA and, a little bit about the ACES program at TMU. And any questions?